Hey y'all, welcome to the first video of Mr. Winter's chemistry videos. I am Mr. Winter. Today we're going to be talking about the mole and Avogadro's number. You are going to need a periodic table, a calculator, and something to take notes on. I have a graphic organizer linked below if you would like to use that, or a good old-fashioned notebook is perfectly fine as well. So let's go ahead and get started. So once again, today we're going to be looking at the mole and specifically Avogadro's number, and basically using this as a conversion, converting between either mass, particles, moles, et cetera, et cetera, et cetera. So first off, what is the mole? The mole is going to be a counting number, much like the dozen. So when I say I have 1 dozen of something, I'm referring to having 12 things. If I have a dozen eggs, I have 12 eggs. In chemistry, we don't use the dozen, we use the mole. The mole says that if you have 1 mole of something, you have 6.02 times 10 to the 23rd things. And we're dealing with lots of different types of things, but really, in the end of the day, we're going to be talking about particles. These particles can be atoms, compounds, molecules, formula units. We'll talk about the different types that exist and that we'll be looking at, but really particles is a perfectly fine thing to be talking about. This right here is called Avogadro's number, named after the Italian chemist Avogadro, Amadeus Avogadro. Avogadro. He didn't discover this number, but they just gave it to him. And it does have an old definition, but we won't even really go there. So they did define this one way, but really now they just define it as 1 mole is this amount of particles. So since we know this, since we know that it's this many particles, what we're going to go ahead and do, clear this, what we're going to go ahead and do is try a problem out. How many atoms of silver are in a 2.5 mole sample? If you would like to try this out, now would be the time to pause the video. But I'm going to go ahead and work my way through this. So we know we have a 2.50 mole sample of silver, which is the element Ag. I like to do my dimensional analysis with a bar and bracket. You can do it however you want. But we know that in a 1 mole sample of silver, I would have 6.02 times 10 to the 23rd, specifically atoms. So that's what we're going to use as our unit. The particle we're dealing with is the atom. We do this multiplication and division, specifically just a multiplication, and we find that we have a sample containing 1.51 times 10 to the 24th atoms of silver, Ag. So that's going to be our answer there. Now, significant figures, wherever you're at, the easiest way to do this is the amount that you start with, which is 1, 2, 3, is the amount that you end with, 1, 2, 3. So let's go ahead and try another one here. We're going to go ahead and scooch along. Mr. Winter, me, finds a sample containing 9.27 times 10 to the 22nd molecules of methane, which is CH4. How many moles are in this sample? So once again, I'm going to take the number provided to me, which is right here, and just rewrite that. So 9.27 times 10 to the 22nd molecules this time. Molecules of CH4. And I'm going to do my dimensional analysis bracket. I know that for every 1 mole of molecules, I have 6.02 times 10 to the 23rd. Now notice in this situation here, the amount of particles goes on the bottom compared to the top. And the reason that is because I want my unit, which is molecules, to cancel out, CH4. So when I do this, I now have 9.27 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. Make sure if you're using a calculator to use parentheses. So by doing this, my answer is going to be 0.154 mole of CH4. So I have less than a mole of molecules in this sample, which makes sense because this number has less than 6.02 times 10 to the 23rd molecules. All right, so one thing to keep in mind when we're doing these types of problems is what type of substance or chemical or compound or thing that you're dealing with. And this is important because of the language and types of problems that you're going to go ahead and see. So first off, when we're looking at compounds, know that a compound is a pure substance made of two or more different atoms, two or more different atoms. So for example, we looked earlier at CH4. That is an example of a compound. I use the word molecule, which I'll define in a second. Sodium chloride, which is table salt, is another example of a compound. And these are compounds because they contain two different atoms, two different elements. So let's go ahead and look at this periodic table here. So this periodic table we see can be separated. So this is a very blank slate of a periodic table, but it's almost every single periodic table is separated. Sorry about that. Is separated by this dark line that kind of staircases down. And this is actually a really important separation on the periodic table. This periodic table is separated into the metals, and all periodic tables, and the non-metals. So everything to the left of the staircase, is going to be a metal, and everything to the right of the staircase is going to be a non-metal. The only exception to this is up in the left-hand corner is hydrogen. Hydrogen is a non-metal, even though it is located on the left-hand side of the periodic table. So keep that in mind for what I'm going to describe next. The reason that this is important is because some of the types of substances on the periodic table can be determined based on where they are on the periodic table. So for example, we have molecules. The word molecule refers to the smallest unit of a covalent compound. All molecules have specific shapes, and they take specific shapes in space. But generally speaking, when I use the word molecule, I'm referring to two substances, two elements that form a bond that are non-metals. So once again, these are composed of two or more non-metals. So when I was looking at my examples earlier, that CH4 is a good example. CH4, because remember, carbon and hydrogen are both non-metals. Carbon is on the right-hand side of the periodic table. Hydrogen isn't. If you want an example of something that is both on the right-hand side of the periodic table, nitrogen trichloride, which is NCl3, is going to be another example of this. Formula units are going to be the smallest ratio of ions that combine to make an ionic compound. Some examples of this are going to be sodium chloride, NaCl, or calcium fluoride, CaF2. Generally speaking, these are going to be composed of a metal, and a non-metal. So the examples one more time would be like sodium chloride, NaCl, or calcium fluoride, which is CaF2. Beautiful. So let's go ahead and try two more problems out. These last problems that we're going to go ahead and look at are really trying to make sure you're paying attention to the language that's used within the problem. So how many atoms are in a 2.59 times 10 to the 24th molecule sample of water? Now, interestingly enough, I don't even really need to convert to moles, because really it's having me just convert between atoms and molecules. So water's formula is right here is H2O. H2O is composed of, it looks like, 3 atoms, 2 hydrogens, and 1 oxygen. So if I am kind of really just paying attention to this, I know that I take my 10 to the 2.59 times 10 to the 24th molecules and multiply this by 3. But I'm going to go ahead and show you the dimensional analysis, because I know that for every 1 molecule of H2O, there are 3 atoms. And those 3 atoms, once again, are 2 hydrogen and 1 oxygen. So this gets us kind of a fun number, 7.77 times 10 raised to the 24th atoms. Cool. All right, the last problem is this. I'll let you guys read through it, and if you want a second to try it out, now would be the time to pause the video and try it out. How many bromine atoms are in a 18.9 mole sample of bromomethane, which is CH3Br? So let's go ahead and get started with this. In 18.9 moles of CH3Br, I want to first find out how many molecules this is. So I know that for every 1 mole, there are 6.02 times 10 to the 23rd molecules of CH3. Br, bromomethane. And I know that for every one molecule of CH3, CH3Br, it seems like there are one atom. There is one atom of bromine. So luckily, if you just kind of stopped it here, you would still get the right answer because you're multiplying and dividing by 1 at the end. But make sure you're paying attention to what the question's asking you. This is asking for bromine atoms given a sample of a molecule, So doing this multiplication out, we find that 1.14 times 10 to the 25th atoms of bromine is what we're looking for. Atoms of Br. Beautiful. So stay tuned. Our next video is going to be on moles and molar mass and doing those conversions there. Have a great day, everyone. Thank you.